Today on the John Ankerberg Show, we will talk about one of the major scientific discoveries of the 20th century, the discovery that the universe had a beginning. We will look at how Edwin Hubble discovered that the universe was expanding, and how he showed Albert Einstein this expanding universe meant that in the past there was a beginning to the universe. Arno Penzias, one of the scientists who discovered the cosmic background radiation of the universe, and who later received a Nobel Prize for his role in that discovery, said that the best data we have concerning the Big Bang are exactly what I would have predicted if I had nothing to go on but the 5 books of Moses, the Psalms, and the Bible as a whole. And of course, the first words of the Bible are, "In the beginning, God created the heavens and the earth." So these scientific discoveries support a theistic view of the origin of the universe. We invite you to join us as we tell how scientists discovered the universe had a beginning. My guest today is Dr. Stephen Meyer, who received his PhD in the philosophy of science from Cambridge University in England. And his book, The Return of the God Hypothesis, is a USA Today national bestseller. We invite you to join us for this special edition of the John Ankerberg Show. Welcome to our program. I'm John Ankerberg, and my guest today is philosopher of science, Dr. Stephen Meyer, who received his PhD from Cambridge University in England. Dr. Meyer has just published another best-selling book, and USA Today says it's one of the best-selling books right off the bat, and it's called The Return of the God Hypothesis. It's your average 550-page book, and the fact is, it is great. I've read it 3 times. I've got everything underlined in this book, and I'm telling you, if you want to know the truth, you've got documented information, and he's a fantastic writer. But Stephen, in our first episode, you told us about the Judeo-Christian ideas that gave rise to modern science. A lot of people don't know that, but that's true. And how that theistic perspective about science fell out of favor during the 19th century. And we need to know why, and we'll talk about that too. But in your current book, you argue that contrary to the perspective that's offered right now by popular new atheists, modern scientific discoveries are doing something to them that's just the opposite. It's bringing about the God hypothesis back into favor. Before we talk about some of those discoveries, tell us, first of all, what are the claims of today's new atheists? You've debated enough of them. What are they?
Well, the new atheists, which would include writers like Richard Dawkins, Lawrence Krauss, Daniel Dennett, Stephen Hawking got into the act near the end of his life. All of these scientists were making the argument that science properly understood undermines the credibility of belief in God. And Dawkins emphasized in particular the role of Darwinian theory in undermining that belief. He said that up until the 19th century, there was strong public evidence for the existence of God in the design that we perceived in living systems. But since the 19th century, we've known that that design is just an illusion. And it's an illusion because Darwin's mechanism of natural selection acting on random variations and mutations can produce that appearance of design without being guided or directed in any way. And Dawkins, who has a tremendous talent for framing issues clearly, goes on to explain that the universe that we observe has precisely the properties that we should expect if at bottom there is no purpose, no design, nothing but blind, pitiless indifference. And this is his key claim, that if you look at the physical world, you see no evidence of design, no evidence of purpose, only evidence of blind, pitiless indifference, and that's what you would expect if scientific atheism, or materialism as it's sometimes called, were true. And I think that's a very instructive quotation because it kind of frames the issue beautifully. Is the universe, in fact, the kind of place that we would expect if there was nothing but blind materialistic processes at work? I think there have been at least 3 major discoveries about biological and cosmological origins, the origin of the universe and the origin of life, that are not at all what we would expect if there was nothing but blind, pitiless indifference, if the materialistic or scientific atheistic view is true.
Thousands of Christians take cruises for their vacations. So why not take a cruise with John and Darlene Ankerberg? Enjoy a prophecy and end times event conference on the water. And when you set sail with them, you'll experience exciting ports and activities, along with uplifting times of worship, Bible teaching, and fellowship. It's more than just a vacation. It's a time to be inspired, refreshed through the study of God's Word, and reconnect with loved ones and friends. So call or go online for more details.
Yeah, let's talk about some of the big discoveries of the 20th century. We've gone 15, 16, 17, 18, we're to the 20th century. You claim that these discoveries are not what scientific atheists should expect to find. One of those discoveries is that the universe had a beginning. How did astronomers first come to suggest this?
Well, this is a fascinating story. It's a kind of astronomical detective story. And it starts in the beginning of the 20th century. There's an American astronomer named Vesto Slipher.
Right.
And Vesto is looking at the nebular structures in the night sky through his telescope. And as he's analyzing the light coming from these distant nebula, he realizes that the light is redder than it should otherwise look. It's the spectral lines have been shifted in a way towards the red end of the electroviolet spectrum. So for your viewers, they probably know that if you shine light through a prism, it will separate into different colors from red to violet. And the red light corresponds to light with longer wavelengths. So if an object in the night sky is moving away from us, then the light would get stretched out and it would look redder than it should otherwise look.
So when you saw the object, it would have a red shift.
It would have a reddish hue, if you will. Now there's different ways the scientists detect that. Now at the time, no one knew whether these nebular structures were just clouds of gas around stars within our own Milky Way galaxy, or whether they were in fact separate galaxies beyond our own. And this was debated right up into the 1920s. But after the 1920s, another astronomer came along named Edwin Hubble. And Hubble began to use these great domed telescopes, the 100-inch Hooker telescope in particular in Southern California. And he was able to also see these nebular structures, but he began to use new methods of estimating distance that were a product of the work of the Harvard astronomer Henrietta Leavitt. And she had worked with observing a strange kind of stars called Cepheid variables, and worked out, on the basis of her work, astronomers were able to develop a method of estimating distance. And one of the things that Hubble discovered was that the Andromeda galaxy, or the Andromeda Nebula as it was called at the time, was 900,000 light years away, whereas the whole scope of the Milky Way was only 300,000 light years across.
Which is what the scientists before that time, they thought that was the entire universe was right there.
Well, some did and some didn't. It was debated. But what Hubble was able to do was to settle the question and show that this particular nebula was a galaxy beyond our Milky Way. And as they measured distances to many of these other nebular structures, it became apparent that we live in a vast universe. In fact, the estimate is now that we have 200 billion or maybe even 2 trillion galaxies in the observable universe. But here's the thing that was even more important. As the astronomers began to analyze the light coming from these distant galaxies, they discovered that nearly all of them were red-shifted. The light was red-shifted. Another illustration of this idea is remember the Doppler shift from high school science. Your science teacher may have told you about how the pitch of a train whistle will drop as the train recedes. And that's because the sound waves also stretch out as a result of a receding object.
But if it's coming at you,
the sound waves would bunch and the pitch would rise, or in the case of light, it would go to the violet end of the spectrum. But with the exceptions of some very, very close-at-hand galaxies, the galaxies throughout the universe are propagating light which is red-shifted in relationship to us. And Hubble further found that the further away the galaxies are, the more red-shifted the light is, the faster they're moving away from us. Now, the only way to explain that is with something like a roughly spherically symmetric expansion, like a balloon blowing up. And so the implication of the red shift evidence was that the universe is expanding outward in all directions of space in a spherically symmetric way. Now that's pretty mind-blowing. We live in an expanding universe, but then it gets even more intriguing when you begin to think in your mind's eye what the universe would have been like at any finite time in the past. If you go back 100 years,
If you roll it back.
like those cartoons where suddenly they make everybody go backwards. So if you go back 100 years, the universe would have been smaller, or 1,000 years, smaller, or 1,000,000 years, still smaller, or 1,000,000,000 years. However old you think the universe is, eventually you're going to go back to a point where that expansion would have had to start. You can't back extrapolate any further. There's a beginning point to the expansion, and arguably, therefore, a beginning to the universe itself. And so the observational astronomy of the 1920s and the evidence provided by Hubble, another colleague of his at Caltech named Humason, implied an expanding universe that was expanding outward from a definite beginning point.
And that blew everybody's mind.
It did, because throughout the 19th century, and really going back to Aristotle, the assumption of most philosophers and many scientists was that the universe was eternal and self-existent. And one of the leading astrophysicists at the time, Sir Arthur Eddington, who actually informed Einstein about the redshift evidence, still didn't like the idea that the universe had a beginning. He said, philosophically, the notion of the universe starting with a bang, he said, is preposterous. It leaves me cold. And a later astronomer explained why this was so upsetting to so many astronomers. He said, an infinitely old universe, this was Robert Dickey from Princeton, he said, an infinitely old universe would relieve us of the necessity of explaining the origin of matter at any finite time in the past. But if the universe has a beginning, we have to look to something beyond matter, beyond the material realm, beyond the physical realm of matter, space, time, and energy, as a cause of that beginning point.
Yeah. So the whole idea of the universe began at some time was on the table. And all of a sudden, Albert Einstein comes along and he develops his general relativity theory that implied that the universe had a beginning. Explain how general relativity, which has to do with gravity, how that implied the universe all came back together.
Right. Well, Einstein actually developed his theory prior to these observational insights of Hubble. He was a little bit after Vesto-Slipher, but before Hubble. And his theory, it was the late 19-teens, called general relativity. It was a theory of gravity. It was the idea that massive bodies actually curve or warp the fabric of space, or what he called space-time, because in Einstein's theory, space and time were connected in very important ways.
I love the way you put this in your book, because I'd never thought about space this way. You know, we think about space as you just drop something, it goes, it's never going to stop. But Einstein had the idea of, think about it as a mat that gymnasts are.
Yeah, like a bowling ball on a trampoline.
On a trampoline.
If you put the bowling ball on the trampoline, it will cause the trampoline to curve.
And any other objects that are like that would keep on piling up.
And then, yeah, if you put some tennis balls around the edge of the trampoline, they'd roll towards the center.
They roll toward that.
So Einstein conceived of space as having a curvature that was produced by massive bodies.
Yeah.
Now that's a pretty interesting idea that was verified or confirmed by a number of observations in astronomy, and it is currently our best theory of gravitation. But it also had implications for the origin of the universe, because if the only force at work in the universe is gravity, then the universe should have collapsed back onto itself as all of space would become curved around the matter of the universe. And as the matter attracted to other matter, everything would curve into a giant black hole. But we don't live in that kind of a universe. Instead, we live in a universe where there's actually empty space between bodies. So Einstein realized that in addition to gravitation, there must be an outward pushing force in opposition to gravitation that accounts for the universe as we see it, which is a universe with empty space. And that implied a dynamic principle in the universe, something that was pushing things apart or expanding, causing the universe to expand, which again got back to this idea of a beginning. Now, Einstein didn't like that idea because it raised these big philosophical and even theological questions about what might have caused the universe to begin. And so he posited that this outward pushing force, what he called the cosmological constant, was of such a precise order it had such a precise value or strength as to exactly balance the inward pull of gravity. So the push outward and the pull inward were exactly balanced, and that way he was able to portray the universe as static, not having a beginning, nor moving towards an end.
Yeah, two things that we'll try to make that are hard to understand in one way, but easy in another way, okay? He wanted to deny that there was a beginning point to the universe, and he used that equation by putting a number in there that made the universe to be static. He fudged,
yeah,
in
he
other
fiddled
words.
with the value of the cosmological constant.
That's right.
In order to get the two forces to exactly balance so he could portray the universe as static.
Okay.
And this again underscores the remark of Robert Dicke, that an infinitely old universe would relieve us of the necessity of explaining the origin of matter at any finite time in the past.
It also shows bias in science.
Well, sure. Einstein had a worldview, a point of view that at the time he was trying to preserve, and his own theory seemed to challenge the worldview, and so he fiddled with the equations. But to his great credit, he later came around, and there's a wonderful story.
He changed his mind.
He changed his mind.
But how did it happen? Because he was a stubborn guy.
Well, he was a very smart guy, but there was a Belgian Catholic priest physicist named Georges Lemaitre.
Yeah.
And on a taxicab ride in 1927, going to a famous physics conference called the Solvang Conference, Lemaitre put Einstein into the picture about the redshift evidence and explained what Hubble and Humason had discovered.
And Slipher too.
And he also explained that Einstein's own equations most naturally implied a dynamic universe, that this fudging that he had done was very ad hoc from a physics standpoint,
Right.
and the universe, even with the fudge, wasn't really static. Any slight perturbation in the orientation of matter would cause a collapse or an expansion. So as a result of that conversation, and a later one he had with Eddington, Einstein went out to Southern California and viewed the redshift evidence for himself with Hubble. And there's some famous newsreel footage where Einstein is peering through the telescope.
And Hubble's
says,
in the background with his pipe looking at it.
Yeah,
and
absolutely. It's famous shot. So 2 weeks later, he gives an interview to the New York Times and tells the reporter that Hubble and his colleague Humason at Caltech have proven that the universe is not static. And later he admits that his attempt to circumvent the conclusion that the universe had a beginning by gerrymandering his own equations of general relativity was, quote, the greatest blunder of my life. And later he came to accept that the universe had a beginning.
it had a beginning. And right away, scientists didn't like that. All the way down through history, you find that people didn't like some of the things that were proposed. And so we developed this whole thing of a philosophy of how do you figure out philosophically which theory is correct. What were some of the alternatives? We'll talk about that theory a little later on, but the fact is, what were some of the theories that were proposed to counter what Einstein said?
Right. So in 1927, Lemaitre was able to synthesize the implications of Einstein's theory of general relativity, which most naturally implied a beginning, with the observational evidence. And that became known as the Big Bang theory. So Lemaitre is really the father of the Big Bang theory. But Sir Fred Hoyle, a great British astrophysicist, and two colleagues, Herman Bondi and Thomas Gold, formulated an alternative theory known as the steady state. They were trying to preserve Einstein's original idea. And they said, yeah, it's true that the universe is expanding, or appears to be expanding, but they said that process could have been going on forever, infinitely into the past. And they proposed that, just as kind of an assumption, that space must have a constant density of matter in it. So as it's expanding now, then the density would go down because there'd be less matter per unit volume. And that stretching of space would cause new matter to pop into existence. So they proposed a kind of continuous creation of matter ad infinitum, infinitely forward into the future, and that process, they said, had been going on infinitely back into the past. So they attempted to get rid of the beginning, but by still accounting for the evidence of an expanding universe.
Yeah. I remember being in graduate school and hearing about that, and it seemed like the view that scientists were pushing very hard. And you want to knock that off now, or you want to wait till the next program?
Let's go for it. I actually had a chance to speak with Herman Bondi my first year as a student in Cambridge. He sat down crisscross applesauce in front of me in a pre-high table drinks thing, and started asking me questions about my research. And then I asked him about the steady state, and he said, well, it was a great idea. The only thing wrong with it, it was completely wrong. He said it didn't meet the evidence. So the steady state theory fell into disfavor among scientists by the mid-1960s. And since that time, most physicists and astronomers and cosmologists have accepted that the universe did indeed have a beginning. And Arno Penzias, interestingly, one of the scientists who discovered the cosmic background radiation and who later received a Nobel Prize for his role in that discovery, later said that the best data we have are exactly what I would have predicted if I had nothing to go on but the first 5 books of Moses, the Psalms, and the Bible as a whole. And of course, the first words of the Bible are in the beginning. So the theistic view of the origin of the universe is that it had a beginning. And I think that's very significant if we think back to that quotation we started our discussion with today from Richard Dawkins, because he says that the universe has exactly the properties we should expect if at bottom there's no purpose, no design, nothing but blind, pitiless indifference. In other words, the universe looks as it should if materialism were true. Scientific materialism is
it shoots his theory down.
But it does. What we have instead is what you'd expect on a theistic view.
That's right.
Not a materialistic or naturalistic view, which denies the beginning. The materialists, after all, have long said that, as Carl Sagan once said, the universe is all there is and all there was and all there ever will be. The universe is eternal and self-existent.
Folks, let me just say that all of these stories and more are in his book, Return of the God Hypothesis. Clearly, he's one of the best writers you're going to ever read. And I wish we could have told this story in a whole hour form, because that's how much information is there. But he did terrific in what he just told you, and it's all true. Next week, we're going to look at the work of Stephen Hawking, who was at Cambridge when Stephen Meyer was a student. And so you got to hear some of his lectures. And Stephen Hawking didn't like the idea of a beginning, but the theories that he came up with reinforced the conclusion of a cosmic beginning. But then how Hawking and other scientists attempted to get around that conclusion, we're going to talk about, was to no avail. But right now, please stay tuned, and I'll have a personal word for you in just a moment.